Have you ever stopped to think about what's actually, powering the digital world?
Mm,
All those websites we use, the games we get lost in, so many of them rely on these really powerful programming languages working behind the scenes.
they really do. And today we're looking at one that's, well, foundational for a lot of that stuff.
Exactly. And it's fascinating because it wasn't just built for raw power, it was designed with the developer, like their experience right in mind.
That's a key point. Accessibility and making life easier for coders was baked in from the start.
We are talking, of course, about C Sharp. That's C Sharp.
Yep, C Sharp.
I first appeared back in 2000. Microsoft developed it. It was a really big part of their whole .NET initiative then.
A cornerstone, really.
Yeah. And the person behind it, Anders Hausberg, he had this really interesting vision. He wanted to mix the power, the control you get with C++ app with the simplicity and speed of Visual Basic.
Right. It wasn't just throwing features together. It was a
Yeah.
deliberate attempt to say, okay, you can have the deep system control like C+++, but let's get rid of the really complex error-prone stuff like manual memory management.
Mm-hmm.
And at the same time, give developers that, productive, almost easy to get started feel
Yeah.
that made Visual Basic so popular, trying to get the best of both worlds, basically.
So, okay, our mission for this deep dive then is to kind of give you the shortcut. We want you to be properly informed about C Sharp.
Get the essentials.
Exactly. We'll look at where it started, its core ideas, right up to the latest stuff it can do now, trying to hit those aha moments without burying you in jargon.
And if you think about the big picture, C Sharp's core ideas really focus on making development better, safer, like type safety.
Right.
It's not just a rule the compiler enforces. It's like this shield that stops a whole bunch of common bugs before you even try to run the code. Think about the debugging time that saves.
Oh, huge. And the automatic memory management, the garbage collection.
Yeah, that's massive. Developers using C Sharp just don't have to constantly worry about allocating and freeing up memory manually. That's a huge source of errors and stress in languages like C++ Wave.
Yeah.
So big productivity boost right there.
And where do you actually use C Sharp? I mean, the range is incredible.
It really is. You've got web development, obviously, with ASP.NET. It powers huge cloud services. Lots of desktop software is still built with it.
Mobile apps too, right? With .NET MAU now.
Absolutely. Cross-platform mobile apps. And then there's the big one for a lot of listeners, I bet, game development, especially with Unity.
Unity relies heavily on C Sharp, yeah.
So it makes you wonder, how does a language from way back in 2000 stay so relevant, even now in 2025?
Good question.
Well, it never stands still. C Sharp just keeps evolving. The latest stable version, C Sharp 13, came out in 2024 alongside .NET 9. It's constantly getting these modern enhancements.
Like pattern matching, you mentioned that.
Exactly. Improved pattern matching, for instance. That sounds maybe small, but it lets you write complex conditional logic, like checking types and values together, in a really clean, readable way. Turns messy if-else chains into something much more elegant.
That sounds like a definite plus for keeping code clean.
Big time.
Yeah.
And performance is always getting tweaked and optimized, too.
Okay, so let's dig into that journey. Starting at the beginning, the basics. If you're new to C Sharp, what's the first thing you notice?
Well, the syntax probably feels familiar if you've ever looked at C++, or Java, or even JavaScript. It's got that C-style curly brace thing going on.
Right. And it's strongly typed.
Yes, very much so. You declare the type of your variables, but it's also pragmatic. It has the var keyword for local variables, where the compiler can just figure out the type for you, saves a bit of typing, keeps things concise, but you still get that underlying type safety.
Makes sense. And code is organized into namespaces and classes.
Pretty much. Namespaces prevent naming conflicts, like folders for your code. Classes are the blueprint for objects. And usually, things kick off in a main method somewhere.
And talking to the user, like basic input-output.
That's usually the console class, console.writeLine to display stuff, console.readLine to get input back from the user. You can do simple things like a personalized greeting pretty easily, especially with string interpolation. That's where you stick variables right inside your strings. Much neater than old-style concatenation.
Okay. And then making decisions, repeating things, the control flow.
Yeah, your standard stuff is there. If-else for choices, switch statements for handling multiple possibilities, and like we said, modern C# makes switch super powerful with pattern matching.
Ah, okay.
And then loops, of course. For loops when, times. For each loops for iterating over collections of data like arrays or lists.
Which brings us to data structures, like arrays and lists.
Exactly. You've got fixed size arrays,
Yeah.
but more often you'll use dynamic collections like list from the system.collections generic namespace. These can grow or shrink as needed.
And methods, functions, basically.
Yeah, methods are where you bundle up your logic. You write a piece of code once in a method, then you can call it from anywhere. Great for reuse, keeps things tidy.
And properties, how are they different from just like public variables?
Ah, good question. Properties look like public variables from the outside, but internally they're actually special methods, a getter and a setter. This lets you control how the internal data, the field of a class, is accessed or changed. You can add validation or trigger other actions. It promotes better design encapsulation.
Okay, so that covers the groundwork. Once you have those basics, where does C# take you next? How do you build bigger things?
That's where object-oriented programming, or OOP, really shines in C#. You start defining your own types using classes. Classes have constructors, special methods that run when you create a new object to set it up correctly.
And inheritance is a big part of OOP, right?
Absolutely. You can create a new class, a subclass, that inherits features from an existing class, a base class. It's all about code reuse and creating hierarchies. Like, a dog class could inherit from an animal class.
And interfaces, they're different from classes.
Yeah, interfaces are more like contracts. They define what methods or properties a class must implement, but not how. This lets you achieve polymorphism, treating different objects in the same way if they implement the same interface. Really useful for flexible designs. And you've also got abstract classes, which are kind of a mix. They can provide some implementation, but leave other parts for subclasses to fill in.
Sounds like a lot of ways to structure code effectively. What about making applications interactive, things responding to user actions?
That's where delegates and events come in. A delegate is basically a type-safe way to reference a method. Think of it like a variable that holds a function.
Okay. Why is that useful?
Super useful for callbacks. Imagine a button in a UI. You want to say, when this button is clicked, run this specific piece of code. A delegate lets you pass that piece of code, the method, to the button.
Ah, I see. And events.
Events build on delegates. They create a formal publish-subscribe mechanism. An object can publish an event, like button clicked, and other objects can subscribe to be notified when it happens. It's fundamental for decoupling parts of your application. The button doesn't need to know exactly who cares about being clicked. It just raises the event.
That sounds really important for building like user interfaces or systems where components need to react to each other without being tightly linked.
Exactly. And for managing data dynamically, we mentioned list_t, but there are other powerful generic collections too, like dictionary T-key, T-value for key-value pairs, or QIT for first-in, first-out scenarios. The key is they're generic and type-safe. A list string can only hold strings.
Catches errors early again.
Right. And handling files, reading and writing.
System.io namespace is your friend there. Classes like StreamWriter and StreamReader make it pretty straightforward. But things can go wrong, right? Files might not exist, networks drop.
Which is why exception handling is crucial. C# has robust try-catch finally blocks. You try the risky code, catch specific errors if they happen, and finally run cleanup code regardless. It stops your whole program from crashing just because of one predictable issue. Makes for much more stable apps.
Okay, and you mentioned LINQ earlier, Language Integrated Query.
LINQ, yes.
Yeah.
This is honestly one of C#'s killer features. It fundamentally changes how you work with data collections.
How so?
It lets you write query expressions, almost like SQL, directly in your C# code to filter, sort, group, and transform data from any source that supports LINQ, arrays, lists, databases, XML files, whatever.
So instead of writing lots of loops and temporary variables.
Exactly. You can write something like from customer in customers where customer city equals London, select customer.name. It's incredibly expressive and readable, a real game changer for dealing with data.
Wow, okay. That sounds powerful. So what happens when we get into really advanced territory, high-performance stuff, modern application patterns?
Right. This is where C# really leverages its modern capabilities. A huge one is the async and await pattern for asynchronous programming.
What problem does that solve?
Think about responsiveness. If your app needs to do something slow, like download a file or query a database, you don't want the user interface to just freeze while it waits, right?
Definitely not. That's terrible user experience.
Async and await make it much, much easier to write code that performs those slow operations in the background without blocking the main thread. Your app stays responsive, fluid. It's basically essential for any modern UI or web application. It changed the game for writing non-blocking code.
Okay, that makes a lot of sense. And generics. We touched on them with collections.
Yeah, generics are fundamental beyond just collections. They let you write code that can work with any data type but still be type safe. You define a method or a class using a type parameter, like my class T, and then you can use it as my class or my class string. The compiler enforces the type safety. It means maximum code reuse without sacrificing safety.
Very cool. What about really low level or meta stuff?
Well, C# has reflection. This is pretty advanced, but it lets your code actually inspect itself at runtime. You can find out what methods a class has, what properties, even invoke them dynamically.
Whoa, when would you use that?
Frameworks use it a lot. Think about things like serialization or dependency injection frameworks or ORMs. They need to understand the structure of your code to work their magic. Attributes are related to codes. They let you add declarative metadata to your code elements, like classes or methods.
Like annotations.
Kinda, yeah. You might put an attribute on a property to tell a database mapper what the column name should be, or mark a test method for a testing framework. It lets tools and frameworks interact with your code in smart ways.
And performance, making things run faster on modern machines.
For leveraging multiple CPU cores, there's the Task Parallel Library, or TPL. It provides easier ways to write parallel code, like using parallel for each to process collections concurrently. It can give significant speedups for heavy computations.
And databases. Is interacting with them complex?
It can be, but C# has tools to help. Entity Framework Core, or EF Core, is a very popular object relational mapper, ORM. It lets you work with your database using your C# objects, and it handles translating that into SQL queries behind the scenes. Abstracts away a lot of the boilerplate database code.
Makes sense. And you mentioned dependency injection earlier.
Yes, DI is a really important design pattern, especially in larger applications and web frameworks like ASP.NET Core. It's about decoupling components. Instead of an object creating its own dependencies, like a database connection or a logging service, those dependencies are injected from the outside.
Why is that better?
Makes your code way more modular, easier to test. You can inject mock dependencies for tests, and more maintainable. You can swap out implementations easily without changing the core logic. It's a cornerstone of modern software design.
Okay. And C# 13, the latest version, keeps adding things.
Always. Things like enhanced primary constructors or collection expressions might seem like small syntax changes, but they often allow developers to write common patterns much more concisely and readably. It's all about reducing boilerplate and making the code express the intent more clearly. These advanced features are what make C# suitable for building today's complex systems, web APIs, microservices, cloud functions, even machine learning with ML.NET.
So looking back at that whole journey, it's pretty comprehensive, isn't it? From the straightforward basics through solid object-oriented design, right up to these advanced modern features like async and LINQ.
It really is. Working with C# definitely helps you build strong skills in software architecture, tackling complex problems, thinking about structure and maintainability.
And if someone's thinking about learning a language now, in 2025, why stick with C# or why pick it up?
Well, its value is still incredibly high. That versatility within the whole .NET ecosystem is a huge plus. You learn C# and suddenly you can target so many different areas.
Yeah, you're not just locked into one thing.
Exactly.
Yeah.
And it runs everywhere now, Windows, Linux, macOS, plus mobile with MAUI. The platform support is fantastic, and honestly, the job market reflects that. Demand for C# skills is strong, especially like we said in game dev with Unity, and definitely in cloud development, particularly with Microsoft Azure.
It really opens a lot of doors.
It does.
You know, it's kind of amazing when you think about it. A language designed over 20 years ago is still so central, adapting to power things like cloud computing, mobile apps, even machine learning now with ML.NET. It keeps integrating these new advancements.
It's constantly evolving. That's the key.
So maybe the question to leave people thinking about is this: how does that unique mix, C# has that blend of power and simplicity we talked about combined with its relentless evolution? How does that position it? Is it just a tool for building apps today, or is it actually acting as the sort of quiet architect for whatever software innovations come next?
That's a good one to ponder. How its design philosophy lets it keep shaping the future.